Now, the last version of RDT, the RDT 3.0. In version 3, we're going to make it very general. So there could be bit errors in the data packet, in the acknowledgement packets, but there could also be losses of the data packets or the acknowledgement packets. So the new assumption here is very general. The underlying channel might have bit errors, but it might also have packet losses, okay, both at the data side as well as the ACK side. Now, all these mechanisms we have in version 2, checksum, X, retransmission, and the sequence numbers to avoid duplicates will help, but only help for, bit errors. So, in case of packet losses, not enough. So we need to add extra mechanisms. And the extra mechanism is this. The sender waits for some amount of time for the ACK to come back. If the ACK does not come back within the time window, then retransmit the packet. Okay, so retransmit the data packet if no ACK comes back within that timeout interval. All right, so what we're doing here is to require setting of a countdown timer per data packet being sent. Okay, so when the data being sent, timer gets started. That timer is going to tick. If ACK comes in before the timer expires, cancel the timer. If there's no ACK coming in and the timer expires, retransmit the data packet. Right? So that's pretty much all to address the packet loss issue. Now, hey, some of you might be wondering, what should be the timeout interval there, right? Hey, internet delay could be changing quite a lot over time. So these data packets can be just delayed, or the ACK packets coming back can just be delayed. So in case they are slightly longer than the timer that we have set up, then we will be retransmitting data unnecessarily. Yes, okay. Some of the retransmissions might be unnecessarily a duplicate. Just like when ACK is corrupted, the retransmission from the data sender in 2.1 is also unnecessary. But it's okay. We already have the mechanism right there, which is the sequence number. That's going to address the duplicate issue. So no worry. Even though if we didn't set the timer quite right, it's just that there'll be a lot more unnecessary retransmission if the countdown timer is too short. All right, so hey, determining what is the duration for the countdown timer, that is also an art. We'll also see later in TCP how that is calculated, how that is estimated. All right, so yeah, sequence number is necessary again in RDT 3.0. The receiver needs to specify the sequence numbers for the ACKs, just like the data side needs to specify the sequence numbers for the data packets. And this is RDT 3.0 sender. Well, the usual technique, let me draw a line. So we just focus on one side of it, you'll see that the other side is similar. So what do we have here? Starting from the initial state, get a call from above, generate the packet, starting from sequence number 0, and what? Wow, we have these timer stuff, right? Starting a timer. And this is the transition next. If everything is going smoothly, receiving an ACK, it's not corrupted, and it's indeed ACK for 0. Then what? Stop timer. Now, if things don't go all that well, and the timer expires, then retransmit the packet and start the timer again. Because, hey, we just sent the data again, then the timer needs to be refreshed. Now, what is a bit unusual is in this transition. So what is this transition in 2.2? Well, the packet coming back from the receiver, if it's corrupted, or if it's clear that it's a negative acknowledgement, previously what did we do? we retransmit packet, right? Like calling UDT send packet here. But we actually do what? Nothing this time. Would that work? If it's, yeah, corrupted ACK or a negative acknowledgement, and we do nothing, would that work? You know what? Hey, there's this transition, right? Yeah, so sender here would just not work in case we get this explicit, okay, signals from the receiver, something is wrong. But eventually the timer is gonna fire as well. So that packet is gonna be retransmitted. It's just that, hey, with these situations, we're just, gonna wait. So we'll just always wait until timeout. Right? How do you like that? Now I'll let you ponder how you like RDT 3.0. In the meantime, let's move on and see a few examples of RDT 3.0 in action. So scenario number 1 here is the no loss scenario. So everything is going well. Data, ACK. So you see, packet 0 being sent, receiver here receive 0 and send back ACK 0. ACK arriving at the sender side, yeah, receive what? Move to the wait for call from above for packet 1 state. So send packet 1, ACK 1, send packet 0, ACK 0, and go on and on and on. So this is a very straightforward scenario. Now the second scenario where we begin to see packet loss. Packet 0 go, ACK 0 comes back. Packet 1 goes, but yeah, dropped. So what's going to happen here? The receiver is not going to receive anything. And the sender side has a timer, right? So that's going to tick, tick, tick until, yep, timeout. Resend packet 1 and restart timer. So ACK 1 comes in. Hey, there's a timer going on here, but because ACK comes in before the timer fires, so that timer gets canceled. So packet 0 go, ACK 0 comes back. So this is the single packet loss scenario. And the third scenario is the ACK loss case. So packet 0 gets out, ACK 0 comes back. Packet 1 goes, and ACK 1 get lost. What's going to happen there is the timer for packet 1 is going to tick and tick and tick until what? Expiration. So this is going to trigger packet 1 being resent, and finally ACK 1 gets received, and data 0 being out again. Now what's a bit unusual here in scenario 3 versus 2 is that, yeah, packet 1 was actually received already, but it's received again because the ACK was the one being lost. Okay. No worry, because this is packet 1 and this is packet 1. For 2 consecutive packets carrying the same sequence number, receiver will not extract data and pass it further on. Receiver just send the ACK back again. Okay, and that's going to clear packet 1, and therefore packet 0 can go on further. Scenario number 4 is to illustrate this case, premature timeout. So that is when the timeout interval is this long, but the ACK and data takes a long time to take a round trip back. All right. The scenario goes like this. Packet 0 goes, ACK 0 back. Packet 1 goes, ACK 1, yeah, takes longer than usual to come back. So at this time point, timer expires, and packet 1 here gets retransmitted. So packet 1 gets retransmitted before ACK 1 can come back here. Right. So when packet 1 gets retransmitted, timer for packet 1 is restarted. But the good thing is, hey, ACK 1 actually just, arrived. So from the sender's point of view, what's going to happen there is sender thought, ooh, ACK for the packet I just sent has arrived, so cool. Cancel the timer and send the next packet. So packet 0 goes. And that's going to trigger ACK0 and come back. And data 1 goes, ACK1 comes back. Data 0 goes, ACK0 comes back. All right. Well, I hope it's just that easy, because we are actually not yet talking about when packet 1 arrives at the receiver, what's going to happen? Well, receiving packet 1 and receiver there will see this is a duplicate because I just received packet 1, right? So this is duplicate. Ignore it. Don't pass it up to the application layer, but still generate the acknowledgement to ensure that the sender is notified. So ACK1 will travel back. Now, sender here received ACK1. That's right after packet 0 is sent. What does that mean? Well, the sender there receiving a corrupted ACK or an acknowledgement that's not quite in sequence number that's expected, then it's probably a negative acknowledgement. So corrupted acknowledgement, negative acknowledgement, that should trigger retransmission in version 2. But in RDT 3.0, what do we do there? We actually ignore it, right? So some of us are not very comfortable about just simply wait until the timer. But you see here, hey, this will actually not trigger any further packet being generated. Okay. You'll see an advantage in the next scenario, where if we run RDT 3.0 with quick retransmission when there's ACK corruption or negative acknowledgement. So you see here, delay ACK, timeout expires first, packet 1 goes first. And ACK1 there generates packet 0 to go, and so on and so forth. Okay. So this generates ACK1 to send. But if, we are not running RDT 3.0, but then RDT 3.0 with what? Retransmission upon corrupted ACK or a negative ACK, then we send what? Packet 0. Okay, again. Because obviously packet 0 is corrupted, therefore we get ACK1. So retransmit packet 0. And that's going to trigger another ACK0. You see, packet 1, packet 1. ACK1, ACK1. Packet 0, packet 0. ACK0, ACK0. So for every data packet, for every ACK packet, there's going to be what? A parallel sending, duplicate of it. Is that good? Even though we try to retransmit early. Not that good either, right? Comparing this case and the previous case. So a trade-off in the design of RDT 3.0 there. Okay, we thought that, hey, delay everything till the timer expires is not that smart. But we ended up saving bandwidth in the end, even though the retransmission is a little bit late.